Hey guys, I hope you've been doing well and that you guys finished out your CMAS test strong. I know you guys did. I will be gone for most likely the rest of the week. Unfortunately, I'm still feeling sick and under the weather, but I'll be back as soon as I can. That being said, we have a little recorded lesson for you guys today, so that way you guys aren't falling behind in any of your content. So today we are going to be going over some square roots. So how do we find and estimate square roots? Also, I'm going to take a moment to pause really quick in case you don't already have your composition notebook with you. Please go grab it. Also, feel free to pause this video anytime you need, whether it's to write a definition or to work through a problem with me, or if I ask you to work through a problem on your own. Make sure you're taking advantage of this being on video and pause, rewind whenever you have to. All right, so a number a is a square root of a number if a squared equals b. So this is a definition that I do need you to write down in your comp notebooks. Please have this whole definition written down. 7 squared equals 49. So 7 is a square root of 49. That's because when we multiply 7 by itself, we get 49. Another thing I want you to write down from this side is a radical symbol and a radicand, and then I want you to draw the visual representation showing what a radical symbol is, which is our square root, and what a radicand is. It is the number within our square root. So please write both of those down, and we'll move on to the next slide. All right, how do we find and estimate square roots? We're going to start simple. So simplifying 81, the square root of 81 is 9. And that's because when we multiply 9 by itself, 9 times 9 is 81. You guys know if I was in class with you, I would have printed you out this chart. But since I'm not, I would love for you to pause this video and write down this entire chart. Yes, I know it's a lot, but I promise you're going to want it. It'll be super helpful, especially when it comes to notes for the test. Simplifying 9 over 16, the square root of 9 over 16. When you have a fraction under a square root, don't let it intimidate you. Think about the numbers individually. So we all know what the square root of 9 is. If you're not sure, reference this little chart and you'll be able to find it right here. Since we found 9, we know that 3 squared is 9. So then we have 3 for our 9. And then we look for 16, and we see that when we multiply 4 by itself, we get 16. So therefore, the square root of 9 over 16 is 3/4. Because when we multiply 3/4 by itself twice, we get 9 over 16. All right, here is another one. So when we have the square root of 64, again, if you have your chart conveniently next to you, you can use that during this time. I also just want you to think about if you have a perfect square, and a perfect square is when you can devise your square root with just one number. There's no remainders, there's no decimals, none of that. So 64 is a perfect square because when we multiply 8 by itself, which you will see right here, you get 64. So simplify the square root of 64, that is 8. All right. Another way to write this would just be rewriting your equation and saying 8. All right, and then simplify the square root of 25 over 81. Again, if you have a fraction, if those individual pieces are also perfect squares, so although 25 over 81 is not a perfect square, 25 is a perfect square, and 81 is a perfect square. So therefore, 25 over 81, the square root of 25 over 81 is equal to 5 over 9. Again, this is because if we doubled this value, we would get 25 over 81. All right, so simple enough, right? Let's move on then. So estimate the square root of 34 to the nearest integer. 34, however, is not a perfect square. So there's two different methods that we can go about this. There's going to be one that I'm going to favor more in our class because we are not given calculators very frequently, but I still want to show you the method just so you guys are aware in real life. So the first method, though, does not involve a calculator. The first method means you find the two closest perfect squares. We don't know what this perfect square of 34 is, but we know that the square of 5 is 25. And then we know that the square of 6 is 36. Since 34 falls between 25 and 36, we know that it has to be somewhere within that range of 5 to 6. Then to figure out exactly which one it is, since we are approximating, these are not the perfect square values, but an approximation of the perfect square. And what that means is it's not exact, but it is the one that it is closer to. So since 34 is 9 digits away from 25, but only 2 digits away from 36, we are going to say that the square root of 34 is about 6. You guys are going to notice we're using this symbol again. We've used this symbol primarily as congruent. It is also universally known as being about. And what about means is similar, same as how we used it last unit. So if you are finding the square root of a number and it is a perfect square, so let's say we are finding the square root of 25, you have to use an equal sign. If you are finding the square root and it is not a perfect square, so you are approximating it, then you will use this symbol instead. So then we would say square root of 34 is approximately 6. All right. So the second method is using a calculator. To use a calculator, you would simply input the function into your calculator. And when I say function, I mean this part, the square root of 34. When you do that, you're going to get 5.8 with a repeating decimal. So then you would round. Since 8 is above 5, you would know to round up to 6, and therefore the square root of 34 is approximately 6. So, like I said, this is the second method. This is one we will not be using very frequently, but if you were asked to approximate a square root, this is another method you could use. All right, estimate the square root of 70 to the nearest integer. So again, when we are approximating square roots, I want you guys to now focus on method 1, finding the square roots that are the closest. So when you're thinking of what numbers are the closest, you can definitely reference these charts that we have and that you should have written in your notebooks, or I would also try to recommend you to just think about your multiplication facts. So off the top of my head, we know that 8 times 8 is 64. And we know that 9 times 9 is going to be 81. So knowing that we have, knowing that we have 8 squared equals 64, and then we have 9 squared equals 81, we know that 70 falls somewhere in between 64 and 81. From there, count the difference in spaces. So the difference between 81 and 70 is 11 spaces, and the difference between 64 and 70 is 6 spaces. Therefore, 70 is closer to 64 than to 81, and then we will say the square root of 70 is approximately 8. All right, we're going to go through a word problem doing the same thing. The process does not change though. Lobster eyes are made of tiny square regions. Under a microscope, the surface of the eyes look like graph paper. A scientist measures the area of one of the squares to be 386 square microns. What is the approximate side length of the square to the nearest micron? All right, so all of that just to tell us that we are looking at the square root of 386, and we're trying to figure out what is the square. In order to do that, we're going to use method 1 again. If there are certain big numbers like this that I let you guys use calculators, I will inform you. Right now, this is a number you guys can do again. Off the top of your head, I know you're probably like, what? No, I can't. But think about what you could multiply to get a number close to it. So 386, my first thought is that is very close to 400. And 400 is a number I know easily has a perfect square of 20. So if 20 times 20, so I will write that out. So if I know that 20 squared would give me 400, and that's very close, then I can try one down. Let's see, and the reason I say one down instead of one up is because 400 is larger than 386. So I want to find one that's smaller. So then I'm going to do 19 times 19. Oops. All right, we get 361. And now we just have to count the difference once again. So you can either just count, you can subtract, do whatever is easiest for you. So 400 minus 386. All right, so for this one, we are going to have 14 spaces difference. And for the next one, we will have 25 space difference. Therefore, the approximate side length of the square to the nearest micron will be 20. So it's about 20 microns. Again, if you need to pause and just reflect on what happened or go through the problem yourself, you are more than welcome to. All right, another one. A contractor is tiling a square patio that has an area of 136 feet squared. What is the approximate side length of the patio? Round to the nearest foot. All right, so once again, we're going to start with putting our squared value under a square root or under a radical. So we have 136. Off the top of my head, I know that 12 times 12 is 144, and 11 times 11 is 121. 136 falls between that. So then we just do the same thing. So 12 squared equals 144, and 11 squared equals 121. Now we just need to find the differences. So we're going to just subtract again. We have 144 minus 136. We have 8 spaces here. And then subtract the next ones. So 136 minus 121. And we have 15. Knowing that there is fewer spaces when we square 12, we know that the patio is about 12 feet. And I'm going to have one last slide of examples that I want you guys to work through first. If you need to pause the video right now before you see me write up the answers, please pause it. I want you guys to actually try to work through these on your own. And then I will write up the answers so that way you can check them and make sure you got them right. All right, hopefully this is you checking back in. So the approximation for these are 15 for number 1, 2 for number 4, 4 for 19, 21 for 447, and approximately 8 feet. For number 5. If you have any questions on these last 5 that I had you guys do on your own, let me know. I can show the work for them as well. But when it comes to the homework, I want you guys focusing on method 1. It is going to be a Delta Math assignment. The Delta Math assignment is going to look a little funky at first. It has a number line on it and a square root that is not going to be a perfect square. I'm not 100% sure about that fact though. There might be a couple perfect squares like like this one that just snuck on in, but there we go, like that one that just snuck on in. So if there are any perfect squares, take advantage of it. But besides that, if there are not, find these squares that are the closest to that given number. And then write what those square roots are, and that will help you identify the two whole numbers that it's the closest between. That's all I have you guys doing today. If you finish early, I want you guys working on either that Tangrams link again or on not Delta Math, on Dreambox. It's up to you. But besides that, I have nothing else for you today. And yeah, I hope you guys are doing well. Bye, guys.